Okay, hello everybody. Welcome to WebAssembly Unleashed, your source for news and views about the world of WebAssembly. As a podcast, we are raw and unvarnished all the time, sort of like an IKEA flat pack of YouTube content. I'm your host, Joel Moses, and aside me today, standing in for Oscar Spencer, is my colleague, Chris Fallon. Welcome, Chris. As well as our good friend and regular, Matt Iacobucci. We spend our time inside this growing WebAssembly community because we're passionate about what hard work can be done with it. And the fact you're tuning in means that you care too. And thank you for that. If this is a return visit with us, thanks you for your loyalty and your subscription. But if it's your first time here, welcome to the party and make sure to subscribe. We've got a great WASM community guest lined up for you today that's also well known in the JavaScript, ECMAScript community, and we're going to talk about the intersection of those technologies with WebAssembly in detail. But first, we've got to do the normal pleasantries. If you've been with us here on the podcast, you know Matt, and that Chris Fallon has been an occasional guest, but he's on co-host duty today, so welcome, Chris. We always start these things with a quick rundown of what you've seen inside the community recently that you think is important or compelling. So do you have anything for us? Chris, what's going on in the community that you think is interesting?
I think sort of the interesting thing with WASM these days is that it's maturing, right? And so things are actually kind of slowing down in some sense, but we're reaching the interesting implementation phase of a lot of technologies. So we have garbage collection now is a feature that's out there, for example. It's cool to see how people are starting to use that and use WASM for real.
Yeah, one thing that I wanted to point out in regards to that is Zig is looking at refreshing their async model or redoing their async IO layer. And it's interesting, Zig has always been able to compile to WASM. They started with that philosophy, but coming into it, redeveloping and coming out with like a very like a re-engineered feature that is thinking about WASM. So they have a couple implementations that aren't going to be immediately WASM supportive, but they are thinking about it. If you read Loris's blog about the design principles there, it's just really wild to see that WASM is a first class citizen here in these things.
That's fantastic. All right, now it's time to introduce our special guest. I want to bring on Oliver Medhurst. Oliver is an ex-Mozilla engineer who's been working in the JavaScript community for a while now. And I had the pleasure of hosting the recent TC39 event where you were an invited expert based on the project we're going to talk about today called Porffor, which is a compiler kit for JavaScript that has some unique features, and among them the ability to ahead of time compile JavaScript to WebAssembly. We're going to dig into that ahead of time business in just a moment, but first, welcome Oliver. Thanks for joining us today. Before we get started, why don't you introduce yourself to our audience?
Yeah, thanks for the invite. I'm Oliver. I used to do Firefox things a few years ago, and since August last year, I've been doing compiling JavaScript to WebAssembly full-time.
That's great. Now, for those listeners who are not familiar with the term, can you explain to us what ahead-of-time compilation is, and maybe dig into why it's a bit of a tricky business with a scripted language like JavaScript?
Yeah, so ahead of time is usually as opposed to just in time, which basically every JS engine today, say like V8, SpiderMonkey, JavaScript core does to try and get the best performance, which is when instead of compiling, say like C++ on the developer's machine, and then you ship a binary to your users, you just ship the source code and then compile on the user's machine. Because that's great for performance, but also tricky for various other reasons, as compilers are. But ahead of time is like C++ or Rust or any other more traditional language, which is you compile your source code on the developer's machine, you ship a blob to your users, and they just run it either natively or with WebAssembly or whatever else.
Now, JavaScript, of course, brings along with it an interpreter, and the interpreter has to be, well, for lack of a better term, you kind of have to ship interpreter logic as part of this. So why is that specifically tricky? Why is that tricky to do?
Yeah, so JavaScript is a very dynamic language. Like anyone who's used it can tell you that it's very hard because like the main things compilers do is statically analyze to be like, oh, like these 5 lines could just be 5 instructions. But with JavaScript, it's very hard to do that because it's just so dynamic that like you could have string concatenation and integer addition are the exact same instruction and look the exact same. It just depends on what data you have at runtime. So yeah, it's very tricky, but I think it's promising.
So I'd love to get more into the type aspect or the dynamic types. I had a ton of questions there, but first, maybe it'd be useful for our viewers to understand why would you want to do ahead of time compilation, right? So like just-in-time compilation has been the standard in browsers for what, 15 or 20 years now, and it seems to work fine. You know, it does take CPU time on the client side, but why would you want to do ahead of time compilation?
Yeah, so there are, I guess, a multitude of reasons. One of which is there are many environments where you just can't do just-in-time. Like, say, you're shipping to an embedded device or like a game console where for security reasons they just don't allow just-in-time, but you still want good performance. Because in some like micro benchmarks, interpreters can be like worse than 10 times slower because it's just interpreting. And then there's other reasons, like say you just want a native binary for your JavaScript. Like say you're making a CLI app, then your only option today is to ship, say, like all of Node.js or like one of those alternatives, which is like 100 megabytes, which is not really ideal. But with ahead of time, you can just ship a like less than 1 megabyte binary, and it just works, hopefully.
And I imagine systems that also launch and process a number of different streams simultaneously, where instantiation cost is at a premium, is also one of those.
Yeah, cloud offerings like say AWS Lambda, they really struggle with cold start times, which is you have to start the entire JS runtime if it hasn't been started recently, which can easily take like hundreds of milliseconds, which for a web request is not ideal. But if you're compiling to WebAssembly or native binary, it's basically zero every time. So it's very nice.
So let's dig into the dynamic aspect of JavaScript a little bit more. You kind of alluded to just-in-time compilation being the standard and that having to do with the dynamism of the language. Maybe could you explain for our viewers like why it's typically good for an engine to sort of observe the program executing before it tries to optimize?
Yeah, so because JavaScript types are so wide-ranging, if you say have a loop which adds 100 variables, just statically, usually you do not know like are those strings, are those numbers, are those floats, are they integers. So just-in-time compilers being able to analyze on the fly, where this function's been run 5 times, it's always been run with integers. I can just rewrite this code to always use an integer. Worst case, you just deopt, fall back to the interpreter, which is still like relatively fast anyway. So it specializes on the fly for those typical situations, which is great usually. But then there's also the problem of the kind of monomorphism of like, say you have a function and you call it 100 times with an integer, then you call it again with a float. You can easily see that one call taking like 100 times longer. Which some big projects, like I think there was the TypeScript compiler, because that's all written in TypeScript and JavaScript. They have had some just like changing a few lines to make things monomorphic, and it's like a 10 times speed up for some functions.
Wow, it sounds difficult to deal with as a developer having these performance cliffs.
Yeah. So like ahead of time, for example, you can't do that dynamic observation. You just have to statically analyze as best as you can, because if you guess, oh, this is always called of integers, but then it isn't, you can't de-optimize on the fly, you just crash.
So are there like ultimately will just-in-time compiling give you best performance, but ahead of time compiling will maybe degrade performance a little bit? That's probably not the right word, but it gives you more consistent performance. You don't necessarily have these spikes and troughs.
Yeah, at least for now, my goal isn't to be as fast as just-in-time. It's definitely to be fast in, say, interpreters, but I think there's a happy in-between of it's like reliably, say, 5 times faster than interpreter and 50% slower than just-in-time. Where like no matter like what types you give it, it has that consistency. But then also, I have experimented with, say, profile-guided optimization, which kind of does the same thing as just-in-time, but that's like its own field, and like also has its own like wormhole of tricks and troubles.
So walk us through. So you're not able to observe the program and see the types. Is Porffor doing any type specialization still with some sort of like ahead of time analysis? Like, are you
Yeah.
inferring types or that sort of
So
thing?
probably there's at least 1,000 lines of code just for type inference and like analyzing types.
Mm-hmm.
It's still, you still have to like only do things if you really know it. So like my inferring is very hesitant to just completely delete code, but if you know this is just a string and then you say like do a plus sign, you know that's concatenation because that's a string, which is really nice. But then say like function arguments, typically you can never infer those types because that could be called of any arguments anywhere. So unless you have really good analyzation, then it's very tricky, which I'm starting to get, but it's still very only does it if it's completely sure.
So for the compiler nerds on the call, I guess it sounds like you're saying you have intra-procedural but not inter-procedural analysis.
Yeah.
Yeah.
Basically.
And
I'm
because
starting to do that, but at least for my optimization approach, I am trying to be very low level intentionally, where it's like WASM instruction by WASM instruction, rather than being really high level, because
Mm-hmm.
it's like much more annoying to do, but the kind of payoffs you get is much wider reaching. Like, say I have dead code elimination, but I haven't specially written that. It just knows, oh, this if instruction is always called with, like, true. So just never take the else path.
I think I saw something about
Like
this
that.
in your repository. You have some partial evaluation. That's
Mm.
approach you're using.
Yeah,
Sorry.
Mm-hmm.
That's super cool.
thanks.
So let's talk about the performance aspects of this. And I know that there's a deficit. You support in Porffor JS to WASM compilation, but also JS to native. And I think native is significantly faster, but WASM is, of course, portable across runtimes for WebAssembly. But compare that to the being able to run a JavaScript routine in WASM itself. What is the benefit of Porffor to JavaScript in WASM?
Yeah, so one of the main benefits is, say, like your website has plugins, and you want to be able to run those with good security. There are some like JS sandboxes today, but they are all like have CVEs yearly at least, because sandboxing JS is very hard. But if you just run in WebAssembly, you have control of every single import and export, like no matter what. So you get that kind of free sandboxing. And also a lot of times it's just like, say my hosting provider only takes WebAssembly for some reason, like they're like specially optimized for WebAssembly, then you just have to have a WebAssembly binary. There's no other way.
And you know, most of the JavaScript tooling for WebAssembly bundles an interpreter inside, and your approach, of course, does not do that. Now, what does that do to both the size and the performance?
Yeah, so for the size and performance, I will get up the data, so I'm not just talking.
You actually have graphs on this one, huh?
Yes. So yeah, so for JS to WebAssembly versus an interpreter, I get like 10 to 30 times smaller binaries. So instead of like 1 megabyte, I get like 100 kilobytes, which is very nice.
Not bad.
And it's similar for performance as well, because you're just compiling instead of interpreting.
Now, I presume, since this is not a full interpreter, that you are essentially you're doing some of the JavaScript interpretation and build yourself. So there's a conformance gap, I imagine. Some things that are supported and not supported. Where is Porffor right now in that?
Yeah, so that's the main trouble of doing this, not even just the ahead of time part, but writing an entire JS engine from scratch.
Mm-hmm.
Because JS is a big language, because it supports the entire web, it has to be. So yeah, I currently support about 60% of the entire language, because there are tests written by the spec authors of JavaScript.
Mm-hmm.
And they cover everything from like basic variables to like for loops to date to newer proposals like temporal, which is like the new fancier way of doing date and time things, which most browsers don't support yet, but later this year.
Does this mean there's an optimum use case for Porffor right now?
Yeah, I think the main ultimate thing right now is just say like I think that the short-term like dream is say you have a CLI app, you can just run it with this and get like a 1 megabyte binary file which you just run instead of like needing the user to install Node.js or something or shipping like 100 megabyte binary of some runtime bundled. Because even with something like QuickJS, which is like the kind of go-to JavaScript interpreter, which is much smaller than say Node or Dino or etc.
Yeah.
But even that is like a few megabytes.
Look, if you could save people from using npm, I think you're gonna have a lot of friends. Yeah.
Yeah, we have plenty of experience with JavaScript interpreters here, both in JS for Nginx directly, and also QuickJS is also supported within the Nginx console complex as well. And yeah, the functionality gap is real as you're implementing.
Yeah, QuickJS is very nice. I think my proudest moment making this so far was I did a benchmark, which is I think like a 2015 V8 benchmark, and me compiling and running in WebAssembly was 2 times faster than QuickJS running natively.
Wow,
Which is
That's
very
impressive.
nice.
That's very nice.
So I'm curious how one even gets started building something as large as a JavaScript engine from scratch. You mentioned the 60% number. Is the way you think of this just you kind of start with like the oldest version of JavaScript and then keep adding like, okay, now I support ES3, now ES5.
Good question.
Are you, building based on I have this one like holy grail thing that I want to run, I'll build everything it needs. How do you go about this?
Yeah, so starting out is more like what is easiest? Like what can I do this week? But now lately it's more of like a target. Like I think like one of my big targets coming up is being able to self-host, which is being able to compile itself fully with its own compiler, which is both very nice to have, but also very hard because writing it, I'm like, oh, I'll use all the new fancy modern JS things, which I now have to support to compile. But say like every built-in API, like say array.push, dates, all of those are all written in TypeScript and then compiled with Porffor to WebAssembly to have those built-in APIs. So I already kind of have that to a degree, which is really nice for that kind of dog fooding. Because I've had it a few times where like, so I was implementing regex, a regex interpreter, which is written in TypeScript compiled by itself. And there's a few things I wrote and then the compiler failed, and I was like, oh, guess I'll fix this compiler bug I accidentally found. So yeah, I think for the most part, it's just have a nice subset, which it's like most things need, which I'm kind of getting to, like say temporal, which is a newer proposal. I probably won't target that for a while because like not even most browsers support it yet. Most people don't use it yet.
Right.
But like the main things I'm lacking is more just I haven't gotten to it rather than for any technical reason.
Yeah.
Cool.
Well, the JavaScript community does tend to be a little bit, how do I say this? A little bit religious in some of its affiliations. I know that you were invited to present at TC39, and what's the reaction in the JavaScript community been to Porffor?
I'd say it's been like surprisingly positive. Like I was expecting some pushback of like we didn't want to learn a new JavaScript engine or like have to deal with new limitations, but I think probably everyone I've talked to has been really looking forward to it. It's just mostly the unfortunate state of like people really want to use it when it's ready, which like there's still not a huge gap, but like a large gap of just getting things to work, which is like an unfortunate necessity.
Yeah, I think on your website, I think on your website you describe it as pre-alpha with usability beginning in 2025. Are you there? Are you there yet?
I'm definitely starting to get that. Like even though the start of this year I was passing, I think less than 40% of the entire spec, so it's been a nice bump. The main thing now is not even just what parts of the JS spec I support, but just like not crashing. Because like I fix most, like say like I can run a lot of things, but if you run them for 30 minutes, I'll have some memory leak and crash. But there's a lot of things like that, which is just like getting it stable.
So does that mean do you have some garbage collection issues, or like with
Yeah,
with the
basically.
okay.
GC is like its own art, and
Yes.
like all my allocation, etc., is very simple, which is just like how can I get this working like well enough. So yeah, for like long-running programs, it isn't that. But my main target probably for this year is say like an AWS Lambda thing, which is just you have 500 milliseconds to respond to a web request. Stuff like that,
Hmm.
I can probably just not have a GC because it will just die in 500 milliseconds. So I just don't have to worry about running out of memory, etc.
So there's the WebAssembly GC proposal, right? An extension to the core bytecode that allows using a host-side GC instead of the thing built in. Um, have you thought about using that or a mode that would use that in Porffor? I imagine there are some shortcomings still with like finalizers and stuff. But yeah, what do you think about it?
Yeah, I think my kind of dream is to have like a setting somewhere which is just I want no GC, I want Porffor's own GC, or I want WASM GC. Just being able to configure that because say you're running in a web browser, that's like the dream for WASM GC. It will run really well. If you're say compiling to C or to like a server-side WASM runtime which doesn't support WASM GC, then you will want to not use that. So I think the
Cool.
dream is just letting the user decide and having some like nice abstraction.
So one other thing I wanted to ask about was the community aspect of this. So we've mentioned, this has gotten, and you mentioned this has gotten positive interest in the JavaScript community, really impressive progress. Uh, have you found that it's been productive in terms of people come in, see it's not ready, and say, "Let me help and contribute"? And has that built kind of a community that's working well, or how have you found that process?
Yeah, so I think the main thing which is like helped me recently is just people filing bugs rather than PRs because
Yeah.
it's just like someone tries to run this code, it doesn't work. Because there's so much JavaScript, it's hard to just know like what to try, like what people are actually using today. So I've had a lot of issues, which is just like here's a JS file, please fix, which is like typically not that helpful, but it's nice to just have the code to sample. And yeah, there's been a few people making PRs, which is really nice. Like one nice thing is like the actual compiler itself isn't that nice to work on because I don't think any compiler is. But say like all the built-in APIs, that's basically just normal TypeScript, which like hundreds of thousands of people probably know because it's basically web dev, but cursed. So it's nice to see people like working on that, and like it's typically pretty easy to work on.
So you mentioned people giving you bug reports. How do you want to be contacted? What's your favorite way? Do you have like a Discord or Zulip or is
Yeah,
it
so
mainly just through GitHub?
so I have GitHub and Discord, which both they use. GitHub is nicer for that kind of organization, but if someone's just like, how do I do like how do I run a file, for example, like if they can't understand the docs, then Discord is great for just being like, here's a command, please try it.
Excellent. Yeah. So for everyone listening, we'll have those linked below.
Definitely. Now you ship essentially a WASM to C engine to C JS as I understand it for compilation. Is there something in WebAssembly that would make it easier for you to maintain or construct a cross compilation utility? Is there something it's missing?
Yeah, so WASM, I forgot which project, but there's like a official WASM to C compiler, which is great, but it's very like it will give you C to like use in a C project. It would just give you a C file to use, like say any imports or exports. It will just give up and make you define them in C, which is fine to a degree, but it's nice because I have my own. I can say like if you have locals, I can name them properly in C for like easier debugging, or I can do a few performance tricks. Like I can recognize an if as an if, not just like, oh, there's like two blocks and an if. I can usually kind of work around that to have a bit faster C performance. But I'd say typically it's fine. There's some stuff, like say WASM GC, I will probably never support that and just move it up the chain as an abstraction. Or some other WASM proposals are kind of tricky, like say, I haven't done this yet, but say like atomics would probably be tricky in C. But I think for the most part, it's pretty nice because a lot of it is just like 1 or 2 lines of C per WASM instruction.
Now, the people that you see that are interested in Porffor, do they tend to be JavaScript people who are looking for ways to gate to WebAssembly, or are they WebAssembly people looking to support JavaScript?
I'd say it's kind of probably not 50-50, but like a lot of interest from both sides I've experienced. Like even just like WASM people say they're making a product which is like a cloud thing that only uses WASM files as input. So many of them want to support JS without having to ship an entire interpreter for like
Right.
various reasons on their side. So a lot of interest there, and a lot of interest from just I want to ship my JS as a blob. Like even regardless of say performance and size reasons, say like you're working on a capture, which like you don't want anyone to reverse engineer for security reasons. Having that as a WASM blob is like probably 10 times harder than like reverse engineering some JS instead.
Now, I know that on your GitHub repo, you at the very bottom, you state that you intend to only use WASM proposals that are common. The ones that are uncommon or draft, you stay away from. Are there some draft ones that you have been tempted by?
But yeah, a few. I think the first one that comes to mind was I think there was a SIMD proposal after the initial one, which I think it might be merged now. It might be
Really?
stage 1 now.
Relaxed SIMD? Is that the one you're thinking of?
Yes, I think that is. I think that's in most engines now, but when I was first doing it, it was still. It was either not in V8 or like behind a flag or something. There's a few ones like that which are really nice, but like especially if say V8 doesn't support it, even if it's behind a flag, most people will just not know how to do that.
Are there proposals or changes to the bytecode that you would like to see that would make it easier to target?
I mean, honestly, the first one that comes to mind is having some way of duplicating a value on the stack without having to use a local. Which I feel like is a tiny ask, but I feel like there's probably a way it doesn't exist. Like there's probably a reason why. But there's just so many times where I have to have some temporary local to do some stack manipulation. Where it's like, I want to swap 2 values on the stack, or I want to duplicate a value. And just, there are no nice ways of doing that.
Got it.
Which is understandable to a degree, but...
So is there anything the community can do for the Porffor project that you would like to see?
I guess the main thing is just harass me with bug reports. Like it's genuinely one of the most useful things. Which is just people trying things and being like, this is broken.
Gotcha.
Like, I can just add that to my list of like things to try.
Got it.
I'm wondering if there's I'm curious, and this is a little bit of a digression, but are there any lessons that other ahead of time compiler people could learn? Like, let's say, I think it's safe to say Python is a popular language, and it also has a similar paradigm to JavaScript being dynamic. Are there generalities that us as a community can learn from what you're doing?
But yeah, I think it's a good question. I think generally my advice is, it might be a hot take, but like sometimes I'll spend days theorizing on like a good way to do something, but just going for it is often nice to just see like what works. Like there's been some things where like, say I'm doing a performance change, and I could spend like easily like days in a Google Doc, like writing bytecode by hand, theorizing, like I think this will be like 50% faster than just doing it and just seeing like kind of real world results is nice. Like when I was first starting the project, I thought it would fail like immediately. Like I thought it would hit some hurdle and be like, I give up. Because I just started it as a side project. And I was like, this will occupy my free time and make me learn more WASM stuff and compiler stuff. But like I haven't hit a brick wall. So it's mostly just iterate, try things.
Yeah. Well, it's certainly impressive progress. We're ticking down to the end here, unfortunately, but I've got one final question, and I just because I've read the GitHub, but just for our listeners, why Porffor? What's the name?
Yes, so I was learning Welsh when I started this project, and Porffor is purple because no other JS engine is purple colored. Like almost everything is yellow or blue or some shade, but I was like, need the SEO.
That's great. That's great. Well, Oliver, thank you very much. Look, you've made a tremendous amount of progress, and it was wonderful to host you here for TC39, and I know that the community really enjoyed the discussion. And as always, thanks for Chris for pitching in as co-host. Before I go, a quick reminder, friends don't let friends jit in production, so compile ahead of time and responsibly. It's a big application world out there, and it's time to unleash the power and promise of WebAssembly. For Oliver, for Matt, for Chris, and myself, thank you for listening in. Be sure to subscribe for future WebAssembly news and views. And until next time, take care.